Hi guys, my name is Annalyn Empactol. So today we're gonna discuss about the ice machine. Ever wonder how an ice machine produces ice so quickly? Whether it's in restaurant, hotels, or your own kitchens, ice machines play an important role in food preservation and comfort. In this lesson, we'll explore what is ice machine, how it works, its main parts, and why it is important in both daily life and industry. What is an ice machine? An ice machine or ice maker is a device that automatically produces ice by pressing water using a refrigeration cycle. It can make different forms of ice like cubes, flakes, and nuggets, used everywhere from homes to hospitals. Ice machine can be classified into two main types. The number one is commercial ice machine, used in hotels, restaurants, and bars. The second one is household ice maker, smaller, portable version found in some refrigerators. The goal of these two is the same, to press water efficiently and deliver clean, consistent ice. Every ice machine has several key components that work together. Let's go over each part and its function. The first one, compressor, compresses the refrigerant gas and raises its pressure and temperature. The second one is the condenser, cools the refrigerant and turns it into a high-pressure liquid. The third is expansion valve, reduces pressures and controls the flow of refrigerant. The number 4 is evaporator, pressing plate or grit, absorb heat from the water causing it to freeze into ice. The fifth one is water pump, circulates water over the freezing plate. The sixth, water reservoir, stores the water supply used to make ice. The seventh is bin or storage, compartment where finished ice cubes are collected and stored. All these parts work together in a continuous refrigeration cycle. How an ice machine works. Let's now look at the process of making ice step by step. Number 1, water fill stage. Water from the reservoir flows over the evaporator surface. The second one, freezing stage. The compressor starts circulating refrigerant through the system. As refrigerant passes through the evaporator, it absorbs heat from the water, slowly freezing it layer by layer. The third one, harvesting stage. When the ice thickness reaches a set level, the machine switches mode. Warm refrigerant or hot gas flows into the evaporator, loosening the ice. The fourth one is ice release. The ice falls into the storage bin. The last is refill. The process repeats automatically for the next batch. This cycle continues as long as the machine has power and water supply. So here are some types of ice produced. Ice machine can produce various forms of ice depending on their design and purpose. The first one is cube ice, hard and slow melting, ideal for drinks. Flake ice, think soft ice used in supermarkets and fish display. Nuggets ice, small, chewable ice used in hospital and fast food restaurant. The last is tube ice, cylindrical ice used in industrial application. Each type of ice serves a specific needs, from cooling beverages to preserving perishable goods.
The primary function of a chiller plant is to remove heat from a closed space within a building. In this video, we demonstrate the process through a truck experiment for easy understanding. A chiller plant comprises 5 key components: the chiller, cooling tower, air handling unit, AHU, condenser water pump, and chilled water pump. Chilled water originating from the chiller's evaporator travels through the supply line to the AHU. The AHU then absorbs all the heat present in the room via the return duct. This heat is transferred to the chilled water coming from the evaporator. Subsequently, the AHU extracts cooling from the chilled water and disperses it back into the room through the supply duct, continuously regulating this cycle. The heat gathered by the AHU is conveyed back to the evaporator via the chilled water return line. Inside the evaporator, the refrigerant absorbs the heat from the chilled water and imparts its cooling effect. The chilled water, now cold, cycles back to the AHU, perpetuating this process. The refrigerant, laden with heat from the chilled water, moves to the condenser. Here, it relinquishes all its heat to the condenser water, absorbs the resultant cold, and returns to the evaporator through the expansion valve. The expansion valve enhances the refrigerant's cooling capacity. The refrigerant, now cooler, imparts this chill to the chilled water. Meanwhile, the condenser water, having absorbed the heat from the refrigerant, is transported to the cooling tower. The heat is then expelled into the atmosphere via the tower's fan. Subsequently, the condenser water, now cooler from the cooling tower, flows back to the condenser. This cycle is relentless, illustrating how a chiller plant extracts heat from a closed space in a building and discharges it into the environment. We hope this video has been informative and aids in understanding the operational principles of a chiller plant. If you found this video helpful, please like and follow for more educational 3D content.
How does a commercial ice machine work? A commercial ice machine works by freezing water to create ice. The machine has a refrigeration system that uses a compressor, condenser, and evaporator to cool and freeze water. Water is pumped into a freezing chamber, where it is sprayed onto a freezing surface, typically a metal plate or grid, which is chilled to below freezing temperatures. As the water is sprayed onto the surface, it freezes into ice. A harvesting system that removes the ice from the surface and stores it in a bin or dispenser for later use. The process continues until the bin or dispenser is full, at which point the machine will automatically shut off until more ice is later. The ice machine can be set to produce different sizes and shapes of ice depending on the needs of the user. If you have any more questions, feel free to give us a call at 281-818-5959.
Your typical ice maker goes through a series of steps to make ice. The first thing it will do is close a set of contacts, energizing an inlet valve which allows water to come into the ice maker tray. This amount is on a timed basis and is designed to make the proper size ice cubes. On some models this is adjustable. So once the water is in the tray, the refrigeration process will turn it from water into ice. Once that happens, the thermostat will now energize a small heater, and that heater will allow the ice cubes to float in the tray. Meanwhile, the ice maker will do a rotation in which a series of fingers will sweep the ice cubes out of the ice tray and allow them to fall into your ice bin. At the same time as it's doing the rotation, an arm will be raised and lowered to determine the ice level in the bucket. If the arm raises and comes down and can't move into its normal position because the bin is full, it will turn the ice maker off. Once the ice is used, the arm will go into its normal position and the cycle will begin again once more.
Maintenance and troubleshooting. To keep an ice machine working properly, regular maintenance is essential. Clean machine regularly to prevent bacteria or mineral buildup. Check water filters and replace them as needed. Inspect electrical connection and refrigerant levels. Avoid overloading the ice bin. Common issues include slow ice production, dirty ice or leaks usually caused by dirty filters, low refrigerant or scale buildup. To summarize, an ice machine uses refrigeration principles to turn water into ice efficiently. It consists of parts like the compressor, condenser, expansion valve, and evaporator that work in a cycle. Whether for home or industry, ice machines make our lives easier by delivering clean, ready-to-use ice anytime.